Hi guys, we're going to be going through how to answer annuity recurrence relation questions, specifically through question 5 of the CSSA Math Advanced trial paper. So recurrence relations is terminology that's more used in the standard course. However, it is a common module that pops up in advanced as well. So recurrence relation is just the formula that you derive from your financial annuities. However, you don't have to do any of the GP sequences for the standard module because that's not taught in their course. So let's go through this example. So we have for question 5, Ali decides to invest $500 at the end of each month into an annuity. The interest rate is quoted at 9% per annum, compounding monthly. So we have let AN represent the future value of the annuity after n months, and we need to find the recurrence relation which models this financial situation. So the best way to start off with these recurrence relation questions is find the value of your annuity after 0 months, or when time is equal to 0. So here, because she's investing $500 at the end of each month, after she's been investing for 0 months, she's going to have $0 in her account because she hasn't started investing yet. So we say that A0 is going to equal to 0. Because it's a multiple choice question, because we got A0 is equal to 0, straight away what I can do is get rid of my options B and my options D because they have A0 as being 500. But we know because she starts investing at the end of each month, after the end of 0 months, she's not going to have any money in her account. We can then see what happens when we go to the value of the annuity after 1 month and after 2 months. So after 1 month, because she's investing $500 at the end of each month, we can say that that's going to be after the interest is put into the account. So she's just going to have $500 sitting in her account. So no interest has been accumulated yet. At the end of the second month, so A2, we know that the money sitting in the account from A1, so this $500 here, is going to be times by my interest rate. So my interest rate is going to be 0.09% per annum, but because we're working in months and because this says that it's compounding monthly, we then want to divide it by 12. So 0.09 divided by 12 give us 0.0075. So in my brackets here, this $500 in our account has been compounded by 0.0075 plus 1. Okay, therefore then at the end of the second month, she adds in another $500. So I can rewrite this as 500, 1.0075 plus 500. To see the pattern, we can do how much the value of the annuity is going to be after the third month. So we have all the money sitting in the account from A2 is then going to be times by 1.0075. So I can write that as that. So A2 times 1.0075, so my interest rate. And then at the end of the month, she adds in another 500. So that's going to be the value of my annuity after the third month. So what we can see is kind of happening here, if I wanted to write what the value of the annuity is going to be after n months, well, because it's going to be the value of the AN minus 1, so the value of the annuity the month before is going to accumulate interest by the time it gets to the month that you're at. And at the end of that month, you're going to add in that 500. So you have AN, your value of your annuity after n months, is going to be the value of the annuity the month before, times by your interest rate of 1.0075, and then add your deposit amount of 500. So having a look at which option the multiple choice gives us this, and it's going to be this option here, A. So that's how you answer those recurrence relation questions without the use of any GPs. You're looking for just a pattern there and seeing how you can write that in terms of AN, and usually AN to the minus 1 as well. So hopefully that helps.